Okay, so we just spent the last day doing ratios and proportions, and all of that was prepare us for geometry problems. We're actually going to be doing 7-2, which is similarity, and triangles, and 7-3, which is basically just the application of it. Okay. Okay, a couple of questions you're going to see. Alright, say similar. I see this question on standardized tests all the time. Now, you're not going to have an EOC this year, but you'll still be taking standardized tests, whether it's the PSAT or your ASVAB or anything else that you need to get into whatever program you want to do after high school. Okay? They want to know, can you tell if they're similar? Can you tell if one is bigger than the other proportionally? Okay? So, I have that trapezoid and that trapezoid, and I tell you trapezoid, and these are isosceles trapezoids, and I tell you this is 2, 5, and 10, and I tell you this is 4, 1.6, and 8. Can you tell me if they're similar? Now, a lot of people would tell me that 5/4, you always, when you do a ratio, remember similarity ratios, you take corresponding parts. So we're going to do 5/4 and 10/8. Okay. And you're going to see if they equal. So you're going to get a calculator out. I forgot to get my calculator. Hold on. You're going to get your calculator out, and you're just going to type in 5 divided by 4. And remember, on these calculators, you're going to hit Control Enter for the decimal version. Alright, so 5/4 as a decimal is 1.25. Then I'm going to do 10 divided by 8. Control Enter, which also gives me 1.25. And so I would have a lot of people tell me that they are similar. But did I check this one? No. And that makes a difference. It is very important to check all the sides of the figure to determine if it is similar. So, let's check this one, just to be sure. 2 divided by 1.6 equals, and in this case, I do get 1.25. Okay? So, in this case, all 3 of them were equal, so your answer is yes, but you have to check all. Okay? So at this point, we turn into decimals. Okay? And again, the key is to check all ratios. Okay? Okay. Then, the next, so this will be example 1, example 2. The next one that you would get is just regular similar triangles. And you probably remember some of this stuff from junior high. You probably had some problems very similar to this. And the problem I always have with this part of the unit is kids get almost a little overconfident, and y'all make the same mistakes over and over again because you think you know how to do it. And you do know how to do it, but you keep making simple mistakes because you're not careful. Okay? Alright. So, I'm going to give you 2 ratios. Or 2 proportions. Sorry, excuse me, I did not use my vocabulary correctly. 2 proportions. And I want you to sit here for a little bit and think about which one is correct and which one isn't. You can pause the video if you need to. Okay? I'm going to go ahead and tell you, hopefully you figured it out by now, this one is correct, but this one isn't. And this is the mistake I see over and over and over again with my students. Okay? They just write ratios and they don't even think about whether or not that the proportion is correct. Okay? If I did 5/x, then I must do 10/4. Okay? I have to stay consistent. One way you can check this is to put a box around your proportion and check all the way around the box. 5 and 10 come from the same triangle. X and 4 come from the same triangle. 10 and 4 match. And 5 and X match. If you look down here, our box, okay, 4 and X come from the same triangle. 5 and 10 come from the same triangle. But 10 and X don't match. Okay? Another correct proportion would have been, it's not the only way to write a proportion, you could do 10 over 5 is equal to 4 over X. In this case, I would have had my arrows from here to here and then here to here. But both ways, again, it's still matching. The arrows are still matching. Okay, so make sure that however you set up your proportion, that you're consistent with how you set up your ratios. Consistency. Okay, if one ratio is set up one way, then the other one must be set up the exact same way to cross multiply and solve. I'm not going to solve that because y'all already know, because y'all learned that yesterday. Okay, next part. Like I said, most of this stuff is pretty simple, so we're gonna go through it pretty quickly just so you have an idea of what's going to be happening. Example 3. Okay. In this case, in this example, you are going to be told that the triangles are similar, and you're going to be asked to solve for X. One thing you need to know about similar triangles, if they got bigger or smaller, did their angles get bigger or smaller? No. The angles of similar triangles are equal. So, if things are equal, all you do is set them equal. Okay. I'm going to go ahead and solve this one by hand because I always see a lot of kids struggle with questions like this. A lot of you try to subtract the 3x, and that's where you get in trouble. Because for some reason I see y'all moving this equal sign around, doing all kinds of crazy stuff. When you're doing algebra, the equal sign doesn't move at all, ever. Right? What is 3x minus 3x? 0. 4x minus 3x is x, and that drops down. Then add 2. For some reason, I have a lot of kids that are afraid of 0. They think 0 can't be an answer. It's just as good a number as anybody else. Don't discriminate against 0. Okay? Okay. Let's do an application problem from 7.3. So this is where 7.3 is coming in. Okay. You can use all kinds of similar triangles to solve stuff. You'll see lots of, if you want to look through the book, there's lots and lots of examples, okay, of different ways to use similar triangles to set up problems. One thing we'll actually do in class is I'll actually get out a mirror and I'll actually get out a mirror and show you how we can do this actual proportion. But you can actually measure, let's say you have a really tall tree that you need to know the height of. You can get out a mirror and go the distance away so that you can see the tree in the mirror and measure it. And if you know that you are 5 feet tall, okay, then you can find the height of the tree. Because if you connect your eyesight to the reflection of the tree, you get similar triangles here. So I can put x over 471 is equal to 5 over 69, and then cross multiply and solve. Another proportion that you could have done, so that one's correct. You also could have done x over 5 is equal to 471 over 69. Both of those would be correct, and both of those would give you the same answer. Alright, that's it. One last thing, if they ask you to write a similarity ratio, That is the same thing as a congruent, or not similarity ratio, similarity statement. If they ask you to write a similarity statement, that's very, very similar to a congruent statement. Remember, when you're writing a congruent statement, the letters, the order of the letters is important. Okay, the order of the letters tell you that these two things correspond, those two things correspond, and those two things correspond. The only difference between a congruent statement and a similarity statement is the symbol in between. That is the symbol for similar. Okay? Other than that, that's it. 10-minute video, not too bad.